Good day, everyone. Today is another beautiful day, and I want to welcome you to the physics branch of a Mathematics Solution Center. Today, we are going to be looking at the period and the frequency of simple harmonic motion. The two types of motion we are going to be studying in this topic today is going to be what? The motion of a pendulum bob and the motion of a spiral spring. Now, the diagram you can see below is the motion of what? Of a pendulum bob. Number one assumption is that the string of the pendulum bob is an inextensible string. And number two is that it is also a weightless string. These are the two assumptions that we will consider in the study of the motion of a pendulum bob. A pendulum bob is a small mass that has weight that is displaced through an angle theta and is allowed to oscillate on its own. Now the object is in motion as a result of its own weight. It will continue to be in motion as a result of what? The weight of the body. Let me quickly show you a video that shows how a pendulum bob moves. Take a look at the motion of this object. At the edges, the potential energy is maximum, while at the center of motion, the kinetic energy is maximum. So at that edge where the potential energy is maximum, the kinetic energy is zero. While at the center where the kinetic energy is maximum, the potential energy is zero. Take note of that in case you see a question. At what point is the kinetic energy maximum? It's at the 0 point, at the center. Why it is what? Zero, the kinetic energy is zero when the motion of the object is about to be reversed. So at this particular point here, potential energy is maximum, while the kinetic energy is zero. While at the center here, the kinetic energy is maximum, but the potential energy is zero. The same thing happens here. Kinetic energy is zero, while potential energy is maximum. Period of an object in a simple harmonic motion. The first thing we have to do, we continue this side line continuously. The weight of an object is always acting vertically downward, and then we use an arrow to indicate the direction of the action of what? The weight. The angle here is still the angle theta, is equal to our angle theta. Don't forget I told you that what? The motion of the object will continue as a result of the weight of the object. It is under motion as a result of what? The weight of the object. Now let's calculate this part of the motion. The component of the weight here is mg. The component of the weight that makes it to be what? In a state of what? Motion. So this part will be equal to what? Mg sine theta. If you use your what? Sine is equal to opposite over hypotenuse. That means this is the weight. This is the component of the weight that is trying to what? Pull it back. And it is a negative force because it acts in the opposite direction of motion. As the object is moving in this direction, the weight, the component of the weight that is trying to pull it back started acting in the opposite direction. That is why it is what? A negative what? Force. With that, we know that what? Force is equal to what? Mass times acceleration. And force is also equal to what? Mg. Because the object, the force that is affecting it is the weight of the object. If you look at this diagram, we can evaluate sine theta here. Sine theta is actually equal to what? X over L. Take note of that. The displacement here over the L. Okay, let's continue. Now we come back here. I've already told you that what? Force is equal to MA and the force is also equal to what? Mg. But the component of the weight that is keeping the object in that continuous and periodic motion is actually what? Mg sine theta. That is the component of the weight that is making the object to what? To continue to oscillate. So let's divide both sides by M. I have A is equal to minus G sine theta. Therefore, we have acceleration is equal to minus g x over L. In our previous lesson, we were able to prove that acceleration is equal to minus omega square x. Don't forget that. You can revisit our previous lesson and you will see this formula there. So I will call this one equation 1 and this one what? Equation 2. Okay, we can equate the two accelerations. Therefore, I have minus omega square x is equal to minus g x over L. So this is the relationship between angular velocity acceleration due to gravity, and the length of pendulum bob. With this, I can say that the angular velocity is inversely proportional to the square root of the length of the pendulum bob. Take note of that. Angular velocity is equal to 2 pi over t. This formula is also proven in our first tutorial. You can always revisit that tutorial to see this relationship. 2 pi over t is equal to square root of g over L. 2 pi over t is equal to square root of g over L. We are going to make t the subject of the formula. In order to make it more easier or more easily explained, I'm going to split the other part into what? Root g over root L. We can now cross multiply. So I have t root g is equal to 2 pi root L. Divide both sides by root g. I have t is equal to 2 pi root L over root g. Therefore, we can combine root L over root g together. Therefore, I have t is equal to 2 pi root L over g. T is equal to what? 2 pi root L over g. So this is the formula for calculating the period of a pendulum bob. The period of a pendulum bob is directly proportional to the square root of the length of the pendulum bob. Don't forget that. Therefore, I have 1 over f is actually equal to 2 pi root L over g. So I have 1 over f is equal to 2 pi root L over root g. Now let's cross multiply. Period and frequency of a spiral spring. At the same time, we are going to be looking at the motion of a spiral spring, and the assumption here is that what? The elastic limit of the spiral spring is not exceeded according to Hooke's law. Now take a look at this particular spiral spring. That is the initial length of the spiral spring when there's no load attached to it. And now a load has been attached, and it has what? Created a kind of an extension or displacement of what? X. According to Hooke's law, the force is directly proportional to extension, provided that what? The elastic limit is not exceeded. Therefore, we can say that our F is directly proportional to what? The X, the extension produced. The work done in an elastic material is given as what? Half Fx, that is the product of the force and the what? Displacement. Just like work is equal to force times distance. So the product of the force and the what? Displacement. But here we are using the average force, or the average work done is half Fx. Now if we substitute F is equal to Kx, we are going to have half Kx squared. Any object that is moving possesses what is called what? Kinetic energy. And the kinetic energy of the material is actually given as what? Half mv squared, which is also equal to what? Half kx squared. Therefore, half is common to both of them. Divide both sides by half. Half goes. Then divide both sides by m. I have v squared is actually equal to what? K over m and then x squared. So we have v squared is equal to what? K over m x squared. Now we are going to take the square root of both sides. I have my v is equal to square root of k over m. Then the square root of x squared is actually x. But don't forget, we are trying to get the period. Therefore, velocity is actually equal to what? R omega. Therefore, I can say that my R omega is now equal to everything. Instead of V, I will replace V with R omega, which is equal to square root of K over M, then S. But R is also displacement, which can be represented as X. Therefore, I can change my word R to X. X omega is now equal to what? Square root of K over M, then S. Divide both sides by X. Therefore, I have my what? Angular velocity to be equal to what? Square root of K over M. This is the formula for calculating the angular velocity when the spring constant is given, and the mass or the mass of the load attached to the elastic material. So omega is equal to square root of k over square root of m. But don't forget that omega is still equal to what? 2 pi over t. Therefore, I have 2 pi over t is actually equal to square root of k over m. Therefore, period is now equal to what? 2 pi square root of m over k. If you should work on the above formula just the way we did earlier, you are going to get t is equal to 2 pi root m over k. So we've gotten our formula. Now we want to get the frequency. Don't forget that period is equal to what? 1 over frequency. Therefore, I have 1 over frequency is actually equal to what? 2 pi square root of m over k. Let's make f the subject of the formula. F is equal to 1 over 2 pi root k over m. We've gotten the second and we've gotten the frequency. Let's solve a problem with all these formula we've derived. A body of mass 20 grams is suspended from the end of a spiral spring whose force constant is 0.4 Newton per meter. The body is set into a simple harmonic motion with amplitude of 0.2 meters. Calculate the period of the motion, the frequency of the motion, the angular speed, total energy, the maximum velocity of the motion, and the maximum acceleration. The first question, we are to calculate the period of the motion based on the parameters given. From our formula gotten above, we have that what? The period is equal to what? 2 pi root m over k. Okay, t is equal to what? 2 pi root m over k. Therefore, we are going to have what? T is equal to 2 pi square root of what is my m is 0.02 divided by 0.04. If you should multiply and divide all these things, find the square root with your pi, everything with your calculator, you are going to get t is equal to 1.41 seconds. Frequency is equal to 1 over t, 1 over the period, therefore, which is equal to 1 over 1.41. Therefore, our frequency will be equal to 0.71 hertz. The unit of frequency is in hertz. Question number 3. What do we have in question number 3? We have the angular speed. Since you know your frequency or your period, you can use any of them to calculate your what? Angular speed. Omega is equal to what? 2 pi f, or omega is equal to what? 2 pi over t. So you already know the value of frequency, you can use this formula, and you already know the value of period, and you can use this. The energy of a spiral spring is actually given as what? Half Ka square. We know the spring constant and the maximum displacement. Therefore, my energy is going to be what? 1 over 2 times 0.41, then times 0.2 square. So press this on, punch this with your calculator, you are going to have 0.008 joules. Then question number 5. Maximum velocity. Thank you very much for watching. We have come to the end of today's tutorial, and we were able to prove all these and given formulas. At the end of the day, T is equal to 2 pi root L over G for a pendulum bob, and we were able to prove that what T is equal to 2 pi root M over K for a spiral spring, also for their frequencies. And the example is also solved. Don't forget to subscribe. Thanks, and remain blessed.